Now let's get some practice with outliers. Let's remember that outliers are numbers that are relatively much larger or much smaller than the rest of the data set. So let's look at these following 4 data sets. Look at the numbers and think which of the following data sets would have outliers. So look at each set individually and think of a general category, or how could you generally describe the range of numbers, and think if there's a number or numbers that are way out of that range or not like the other numbers at all. Think of them as outliers. So we can see in set A that most of the numbers are in the teens or the 20s. We have 13, 18, 22, 25. But then you have the number 1. 1 is a single digit. It's our first whole number, our first counting number. It's much, much smaller than the rest of the data starting up at 13. Set B also has numbers higher in the 50s, 60s, 70s, 80s, and 100s, and then you have one lower number much smaller than 52, the lowest other number of 17. So set A and B have outliers. This is different from set C and D, where you have just a gradual change in the difference between the numbers. It's not such a large difference. So when it's not as obvious, though. It takes some practice seeing what does that mean, relatively larger or smaller. So when an outlier is not obvious, a general rule of thumb is that if the outlier falls more than 1.5 times the interquartile range below Q1 or above Q3, it's considered an outlier. So if the number falls more than 1.5 times, again, the interquartile range below Q1 or above Q3. And that's confusing in itself. So let's actually take a look at an example. So we have this set 1, 5, 6, 9, and 17. So quartile 1 would be 3. Quartile 2 is 6. So quartile 2 is the median. And then you have quartile 1 is the median of your lower half. Quartile 3 is 13. That's the median of your upper half. And the interquartile range is the difference between Q3 and Q1. So 13 minus 3, that's where we're getting 10. So now we can use 1.5 times the interquartile range. So that'll be 1.5 times 10, and that equals 15. So we can do 15. We can subtract 15 from the first quartile 1. So 3 minus 15 is negative 12. And then we can add 15, that new number. We can add that to quartile 3, and we get 13 plus 15 is 28. So in order to be an outlier, a number should be smaller than negative 12 or larger than 28. So in this case, we don't have any outliers, 1, 5, 6, 9, and 17, because none of those numbers is negative 12 or higher than 28. But let's say I added to this data set, let's say it was comma 100. So 100 is much greater than 28, so that would be considered an outlier. Or if I added to this data set over here, even if I added negative 13, even though it's only 1 less than negative 12, it's smaller than negative 12, so that would be considered an outlier. So we can use this as a general rule of thumb when it's not as obvious that an outlier has occurred.